processing. I some teach you about it by 5 minutes. So please subscribe and press the bell icon and start the topic. In signal processing, sampling is the reduction of a continuous time signal to a discrete time signal. A common example is the conversion of a sound wave to a sequence of samples. A sample is the value of the signal at a point in time and or space. This definition differs from the terms used in statistics, which refer to a set of such values. A sampler is a subsystem or operation that extracts samples from a continuous signal. A theoretical ideal sampler produces samples equivalent to the instantaneous value of the continuous signal at the desired points. The reader signal can be reconstructed from a sequence of samples up to a Nyquist's limit by passing the sequence of samples through a reconstruction filter, and its theory functions of space, time, or any other dimension can be sampled, and similarly in two or more dimension 5 function that vary with time, and let s t be the continuous function or signal to be sampled, and let sampling be performed by measuring the value of the continuous function every t seconds, and which is called the sampling interval or sampling period. Then the sample function is given by the sequence s and t for integer values of n, and the sampling frequency of sampling rate fs is the average number of samples obtained in 1 second. Thus fs is equal to 1 by t, and which is the with the unit sample per second, and sometimes referred to as hertz. For example, for 48k, as that is 48,000 samples per second, and reconstruction a continuous function from samples is done by interpolation and algorithm. The Whittaker-Shana interpolation formula is mathematically equivalent to an ideal low-pass filter whose input is a sequence of direct delta functions that are modulated multiplied by a sample values when the time interval between adjacent samples is a constant t, and the sequence of the delta function is called a direct comb, and mathematically the modulated direct comb is equivalent to the product of column comb function with s and t. That mathematical abstraction is sometimes referred to as impulse sampling. Most sampled signals are not simply stored and reconstructed. The fidelity of a theoretical reconstruction is a common measure of the effectiveness of sampling. That fidelity is reduced when s and t contains frequency components whose cycle length and period is less than 2 sample interval C aliasing, and the corresponding frequency limit in cycles per second, and hertz is 0.5 cycle by sample, and multiply f and s sample second is equal to fs by 2 and known as the Nyquist and frequency of the sampler. Therefore s and t is usually of the output of a low pass filter, functionally known as an anti-aliasing filter. Without an anti-aliasing filter, frequencies higher than the Nyquist frequency will influence the samples in a way that is misinterpreted by the interpolation process. And practical considerations: in practice, the continuous signal is sampled using an analog to data converter ADC, a device with various physical limitations. This results in deviations from the theoretically perfect construction, collectively referred to as distortion, and various types of distortion can occur, including aliasing and aperture error. And aliasing, some amount of aliasing is inevitable, and because only theoretical infinitely long functions can have no frequency content above the Nyquist frequency, and aliasing can be made and arbitrarily small by using a sufficiently large order of the anti-aliasing filter. So friends, how is my topic? I hope you like it. So now you give me permission. I am go to my new BAF topics. Take care. Allah Hafiz.